Welcome back, everyone, to another college algebra lecture. Today we are going to begin on chapter 4, and our first lesson is discussing composite functions. Now, composite functions is a pretty straightforward concept. All it is taking a function of another function. So looking at our definition, if you're given two functions, f and g, the composite function, f composed with g, that's how we would read this, f, the little circle is composed with g, is basically defined as f of g of x. Now, when you're writing this out, the order that you put this does matter. The first one is always your outside function. The second one's the inside function. And that's very important because whichever function's on the inside is the one that affects our x value first. Now, one thing I want to draw your attention to, the little circle means composed. It is not multiplication. So you would not say that this is f times g. All right, now the way that all this is going to work out to begin with is we're going to be evaluating these composite functions at a particular number of values. So a good way to think about composite functions is as a machine. We know from our discussion about functions that a function takes an input and gives you an output. Your input will be a number, stick it into your function, you get a number out. Now all we're going to do is take the number we got out from our inside function and stick it into the outside function. It'll do its magic and we get a final number out. So that's basically it. You put an x value in to the inside function, you get a value out, and you take that value, put it in your outside function, and you get a new value out. And that's all you have to do for composite functions. Only other thing to mention before we move on to working some problems, the f composed with g, that's the proper notation, but it's not the most user-friendly way of writing it. The easiest way to write this is using this notation right here, f of g of x. That makes it a lot smoother to work with. All right, so looking at our first problems, I want us to evaluate some composite functions at particular values. So looking at example 1, I tell you that f of x is equal to 3x minus 1 and g of x is equal to 5x plus 4. The first thing I want us to evaluate is f composed with g of negative 3. Now again, that's not the most user-friendly way to write this, so I'm going to start by rewriting it. Rewriting this, I know I can write this as f of g of negative 3. F is first, so it's the outside, g is second, so it's the inside. Now, once you see it written like this, it's a lot easier to process because I see that the g and the negative 3 go together first. So to evaluate this, I'm going to first do g of negative 3. Evaluating g of negative 3, I have my g function. Anywhere there's an x, I'm going to put my negative 3. So I have 5 times negative 3 plus 4. Doing that, I get negative 11. So coming back up here, I now have f of g of negative 3 is negative 11. Now I can evaluate f of negative 11. So using my f function, I have 3 times negative 11 minus 1. This winds up giving me negative 34. So my final answer is negative 34. So talking through how we did this again, rewrite it in the user-friendly notation. The one you evaluate first is the function that's closest to your number. So g of negative 3, I evaluated it, got a number value out. Then I take that number value and I put it into my outside function, f. Evaluate again, and our final number is what we get. And that's it. Nothing else to do. So doing this again, I now want to do g composed with f of 4. First things first, I'm going to write it in the user-friendly notation. G's first, so G's on the outside, then f of 4. So now I see that I need to evaluate f of 4. So I have f of 4 Now I look at my f function, I'm going to have 3 times 4 minus 1. That gives me 11. Therefore, I now have g of 11. Evaluating this one, I now can do 5 times 11 plus 4. This gives me 59. So my final answer is 59. That's all you got to do. Now, these next two I put on here to show you that you can compose a function with itself. It doesn't have to be two different functions. So looking right here, I'm going to do f composed with f of 3. So writing this out, I have f of 3. So now I start with f of 3. Doing this, I have 3 times 3 minus 1. That winds up giving me 8. Now I know I'm going to be doing f of 8. So f of 8, I have 3 times 8 minus 1. That gives me 23. So my final answer is 23. All done. And for the last one, rewriting it, I have g of negative 1. So starting here, I have g of negative 1. G of negative 1, I have 5 times negative 1 plus 4. That gives me negative 1. Now I have g of negative 1. That looks a little familiar. That's the same exact one as that. But just because I'm a completionist, I'm going to go ahead and write it down again. But if you already saw it's going to be the same thing, you could skip straight to the answer. All done. So hopefully you found these to be pretty straightforward and easy to do. If you're given the two functions and I ask you to find the composite at a particular value, rewrite it in the friendly version, and then substitute your number into the inside, get a number, substitute that one into the outside. Nothing else to do. Now, if you're already good to go after this one, please feel free to skip ahead. I am going to do these down here, and I do want to mention something special about A and B. So if you're sticking around for this, I want you to notice that for A and B for this one, I have G or F composed with G of 1, and then G composed with F of 1. Now, I'm evaluating at the same X value, but I'm not guaranteed to get the same number out because the functions have been reversed. This isn't the same as multiplication where you can switch them back and forth. Composition is non-commutative. Okay, so doing this now, I have f of g of 1. So evaluating first, I have g of 1. That's going to give me, looking at my new function, 4x to the third plus 1. So I have 4 times 1 to the third plus 1. Doing that, I wind up getting 5. Now I'm going to do f of 5. F of 5, look at my new function, 2x squared plus 5x plus 3. I have 2 times 5 squared plus 5 times 5 plus 3. Evaluating this, that's going to give me 25, 50 plus 25, so 75 plus 3 is 78. So my final answer is 78 on this one. Okay, now doing this next one, I have g of f of 1. I will start by doing f of 1 now. So I have 2 times 1 squared plus 5 times 1 plus 3. That gives me 10. So I can already tell that this is different. Doing g of 10, I have 4 times 10 to the third power plus 1. 10 to the third is 1,000 times 4 is 4,000 plus 1 is 4,001. So even if they're evaluated at the same x value, reversing the composition gives you drastically different answers. All right, now you're all probably good after this, but just because I want to complete everything, I'm going to put these on here. So if you're already good to go, please skip ahead to the next page. Doing this, I have f of negative 2. So I have f of negative 2. That gives me 2 times negative 2 squared plus 5 times negative 2 plus 3. Valuing this, that's 4, 8 minus 10 plus 1 gives me 1. F of 1, 2 times 1 squared plus 5 times 1 plus 3. This I've already evaluated up here, so I know it's going to be 10. So this was f of 1, which is 10. All right, and now for my last one on here, I have g of negative 1. So g of negative 1, I'm going to have 4 times negative 1 to the third power plus 1. That gives me negative 3. So g to the negative third, or g of negative 3, sorry. So now I have g of negative 3, 4 times negative 3 cubed plus 1. That's going to be negative 27 times 4 is negative 108 plus 1 is negative 107. All done. So hopefully you found these all to be pretty straightforward and easy. All right, moving on. We are still going to be evaluating at particular numbers, but I'm going to show you a different way to go about it. Instead of giving you actual functions to look at first, I'm now going to give you a table of values. So right here, this table of values represents the x values and the g of x values for those particular x's. This one's for f of x, and then over here, we want to find g or f composed with g of x. Now, there's a really quick way to write these down, but I'm going to show you the more detailed version to help you get a better understanding. After doing it my way for a couple of times, you can probably start doing it the really fast way. So to start with, I'm going to write this the friendly way. This is f of g of x. Got it. Now, looking right here, the x value I'm going to plug into this is negative 2. So this is f of g of negative 2. Well, seeing it written this way, I see what I need to evaluate first is g of negative 2. So coming over here, g of negative 2 gives me 4. So this is now f of 4. Now I see I'm going to come over to the f column and I'm going to evaluate where f is 4. I wind up getting 7. That's it. All we're doing is tracking down the individual values. I started with negative 2 and g was on the inside. So negative 2 went to g right here. I take this 4 to the f column and I got 7 out. That's it. That's all you have to do on this one. Okay, so next one up, I have f of g of negative 1. So I know this is going to be f of something. Looking right here, going to g, I get 1. And then here goes to 4. All done. Now, f of g of 0. Starting at 0 goes to 0, 0 goes to 3. So you've probably already picked up that there's a faster way of writing all this down. You don't have to write all this as long as you know how to track the numbers properly. You can just go straight into the answer. But if you need the extra detail or you think you might get mixed up what goes where, writing this will help you out. So now I have f of g of 1, and that's going to give me f of some number. So looking for g is 1, right here goes to 1, 1 goes to 4. Got it. And now f of g of 2, starting with g at 2, that goes to 4, and then 4 goes to 7. Got it. We have every single thing that we need. All right. So one more, just in case you need it, but if you don't, feel free to skip down to the next problem. So now, writing this one the friendly way, I have g of f of x. So I know for all of these, g is going to be on the outside, f will be on the inside. And once I evaluate, I'll get g left over, and it'll equal some number. So I'm a bit on the lazy side. I'm going to go ahead and fill all this in because I know what I'm doing now. I knew what I was doing before, but now it's just extra reinforced. G of f of 1 and g of f of 2. All right, now let's do it the fast way. So negative 2 is first. F is the one I evaluate. So f to negative 2 goes to 8. And then 8 goes to 20. Next up, negative 1 goes to 1. And 1 goes to 6. Now 0, 0 goes to 0, 0 went to 4. Now I have 1 goes to negative 1. Negative 1 goes to 2. And lastly, 2 goes to negative 8. Negative 8 goes to negative 12. All done. So did I write extra? Yes. Was it faster to do it the other way? Yes, again. But this gives you more detail that might help you out if you get a little lost. So using the chart should be pretty straightforward and kind of fun. Now, for the last problem on the page, I'm going to give you 2 graphs to look at instead of a table of values. But we're going to go through this very, very similarly. So to start with, I have f of g of 7. So f of g of negative 7. When I do this, I have to start with g of negative 7. So that means I'm going to look at the g graph over here. So my x value is negative 7 right there. Going to the y value, I found this value right here, which is negative 4. So I have f of negative 4. Now I'm using the f graph, and I'm going to go to where x is negative 4, which gives me this value, which is negative 5. That's my answer. So rewrite it, evaluate the inside using the graph you have. That's the x value. G of that x value will be the y value that corresponds. Fill it in, and then use the new graph, or whichever one you need. All right, so doing this one, I have g of f of 1. Starting with the f graph on this one, I go where x is 1, which is right here. My y value is negative 2. So this is now g of negative 2. Looking at the g graph, here's negative 2. Negative 2, that looks like it's right here, which is the 0 of that graph. Got it. Now for this next one, f of negative 2. I start with f of negative 2, which is right here. I get negative 5 out. So I have f of negative 5. Now I go to where f is negative 5, and I get this value, which is -4. It's just tracing the dots over. And now for our last one, I have g of -1. So I start with g of -1. Coming over here, here's g going to -1. Looks like that's -4 to me. So g of -4. Now I go to where g is -4, which is right here. I get 5 out. That's the final answer. All you have to do. So you can use a table of values to go through and fill everything in that you need, or you can use 2 graphs. And depending on the book that you get homework out of, sometimes the graph will be separate like this. Sometimes they'll give you one set of axes with 2 graphs on the same line. Just make sure you pay attention to which one's labeled F and which one is labeled G. All right, so now we're going to go on to the last page. In the last page, we move away from evaluating in particular numbers, and we move into finding the function version of the composite function. And when I say the function version, what I mean is writing it out using numbers and x's. And this is kind of straightforward-ish. The only thing that gets a little detailed is whenever you're asked to find the domain, which finding the domain is actually pretty straightforward, but it's going to be a 2-step process. All right, so looking at this first one right here, I'm given f of x equals 5x squared plus 15, and g of x is 2x minus 3. What I want to evaluate first is f composed with g. So doing this, I now have f of g of x. Well, writing this a different way, I have f on the outside. I know what g of x is. G of x right here is 2x minus 3. So I'm going to fill that in, 2x minus 3. Well, we know how to handle this now because we did this back when we talked about functions in chapter 1. I'm going to look at my function f. Anywhere that there is an x, I now put parentheses x or 2x minus 3. So filling this in, looking at f, it starts with a 5, so I have a 5. Now I have x, so I'll replace that x with 2x minus 3. I have to put a square on it, and then plus 15. There we go. And hopefully if you look at this, you'll see that this is the 5x squared plus 15 from above. And instead of x, we now have g. Okay, so going through and doing some algebra, this right here needs to be expanded. So hopefully remember that square means times itself. This will be 2x minus 3 times 2x minus 3. So I will leave you to practice the distributing out on your own. If you distribute correctly, you should get 4x squared minus 12x plus 9. And then I still have my plus 15. And again, this came from expanding that. 2x minus 3 times 2x minus 3. Then distribute and combine like terms. Now at this point, I need to distribute my 5. That's going to give me 20x squared minus 60x plus 45 plus 15. The last thing I need to do is combine these terms, and I get 20x squared minus 60x minus 60. This is the function version of that. Now, at this point, you might be wondering, why did we just go through all the headache of doing this? Well, the reason is, imagine I took this same problem back to the first page, and I asked you to evaluate f of g of 1. You would have to plug it into the inside, and then get a number, plug it in the outside, and then you get your final answer. Well, then what if I give you an entire long list of numbers to evaluate at? You would have to do that double evaluation for each one. That gets very tedious very fast. Well, now, since we know what the function version of this is, If I gave you a long list to evaluate at, you can just substitute it into this new function and find all your numbers a lot faster. That's the power of this one. It makes evaluating a lot quicker. Now, the last thing we have to do on here is find the domain. And if you remember, the domain of a function are all the x values that we are allowed to use. This is going to be a two-step process for us because we have to look at the original function on the inside. What x values can I use here? Then look at your new function that you ended with. What x values can you use there? So looking at this step right here on the inside, I see I can use every single x value possible. I don't have any square roots. I don't have any fractions. So the domain there is negative infinity to positive infinity, or all real numbers. Now looking at this one, the domain for my final one, I don't have any square roots. I don't have any fractions. It's negative infinity to positive infinity again. So these two match up. So my final domain for the entire function is negative infinity to positive infinity. So again, talking you through this, look at the original. You have to figure out what the domain for the original is, and then look at the domain of your final answer. All right, so let's do this again. And this one will be a little bit quicker. So right here, wrong color. I'm evaluating g of f of x. So I'm going to start by writing down g of, now for this f of x, I know that to be equal to 5x squared plus 15. Now going through doing the rest of it, I'm going to fill in what g is. G starts with a 2. Then I have an x. So instead of x, I'll put 5x squared plus 15. And then I finish it with the minus 3. This looks the exact same as g, except the x is now g of x. Simplifying down, that's going to give me 10x squared plus 30 minus 3. Now I have 10x squared plus 27. That's my final function version. And now looking at the domains, I see for the inside right here, I don't have any square roots. I don't have any fractions. I get negative infinity to positive infinity. Right here, same situation. So my final domain on this one will be negative infinity to positive infinity, because I don't have any contradiction between these two. Okay, that's how you do it for those. Now at this point, you're probably wondering, well, is it always going to be negative infinity to positive infinity? Answer is no, it will not. And we got an example to show you that. All right, so coming down to this next one, I'm going to start the same way. This is going to be f of g of x. So filling this in, I have f of, I will have 2x plus 7 on the inside. Now f starts with the square root, so I have my big square root. Then I have x, so I'll have 2x plus 7, and then a minus 1 behind it. So this is what x was, and then the minus 1 came from the original. Simplifying this down a little bit, I now have 2x plus 6. Done. Now, figuring out the domain on this one, for the inside, I have negative infinity to positive infinity for the domain. But for this one, I have a square root. So if you remember, I have to be careful. I have to say 2x plus 6 is greater than or equal to 0. Because for the domain of a rational, it has to be greater than or equal to 0. Solving that, I get x is greater than or equal to subtract the 3, or subtract the 6, divided by 2, we get -3. These two don't match. So I have to go with the one that is the smallest or the most restricted, so it works for everything. Now this one in interval notation, which is really what your homework is going to ask you to use, would be bracket, because it has the equal sign, -3 to infinity, because it's greater. So my final domain on this one, the way you pick it is you have to use the most restricted version. I can't use all real numbers in this. This is the biggest I can use. -infinity to 3. That's it. That's how you figure it out. Compare the domain of the original to the domain of the final. Use the one that's the most restricted because that works for everything. All right, if you didn't quite get it after that one, let's look at another. Right here, this is going to be g of f of x. So I start with g. Now I'm going to write down what f is. That is the square root of x minus 1. Now I have 2 times square root of x minus 1 plus 7. That, I can't distribute the 2 anywhere, so it's just going to be 2 square root x minus 1 plus 7. That's as simple as it can get. Now comparing them, looking at the original, I have x minus 1 greater than or equal to 0. That tells me x is greater than or equal to 1, which in interval notation is bracket 1, comma, infinity. Looking down here, the only thing I have to worry about is the square root. Oh, let me scoot this over. Only thing I have to worry about is the square root. The 2 and the 7 aren't going to affect me. So doing the square root is x minus 1. Same right here. So they are the same. So my domain on this one is 1 to infinity. So hopefully it's getting a little bit better for you. If not, I have one more example to show you. Okay, so looking at the final one, and this one's kind of fun how everything plays out. Starting as usual, I have f of g of x. So I have f of my g is x plus 4. So now looking at f, I start with x, so I'll do my parentheses. Now I have square root of x plus 4 squared minus 4. Now simplifying down some, right here, the square root and the square are going to cancel, so I get x plus 4 minus 4. And now I end up with just x. So my final version when this one fully simplifies is just x. Now, looking at my domains for the original inside, I see that I have to be x plus 4 greater than or equal to 0. That gives me x is greater than or equal to -4. So -4 to infinity. Looking at this one, there's no square roots, there's no fractions. This one's -infinity to positive infinity. The one that is the most restricted, the smallest one, is this one right here. Every single x in here will work, but not every x right here will. So my domain is -4 to infinity. Got it. Now for my last one, I have g of f of x. So I have g of x squared minus 4. Continuing on, this is now square root because that's what g starts with. instead of x, I put x squared minus 4, and then plus 4. There we go. Right here, the 4 and the negative 4 cancel, so I get square root of x squared, which is just x again. They both ended with x, which is actually something pretty special that we're going to talk about next time. Now, finishing this up in the domain part, right here, there's no square roots, there's no fractions, so I have negative infinity to infinity. Looking right here, this one, again, no square roots, no fractions, negative infinity to infinity. So my domain is going to be negative infinity to infinity. They match. I can use every single x value in this function, and it works just fine. But this one over here, if I were to set this one up, and this is what I originally had, I can't use any numbers less than negative 4, or else I'm taking the square root of a negative, and that breaks my function. And that's it. So for composite functions, the only tricky thing that we ever have to worry about is figuring out what the domain is. And hopefully, if you followed all my tips, it should be pretty straightforward to get a handle on. But other than that, that's it for composite functions. We will see them again next lesson because composite functions are a tool we use for the next piece. But other than that, if you have any questions, please feel free to contact me. I'm always happy to help you out. Other than that, have a great rest of your day.